Hello everyone, this is Naveen Kumar. Today my topic is about techniques in wind tunnel testing, and my roll number is 21955A2106 from Aeronautical Engineering branch, and topic is about the significance of similarity parameters. And basically, the similarity parameters are used to find out the other parameters while keeping other parameters constant. And in that similarity parameters, uh, how the internals are used are going to use these similarity parameters to find out the other parameters is about the complete PPT is all about that. And these aerodynamic analysis, first of all we'll discuss about the aerodynamic analysis similarity theory. In this aeronautical engineering, similarity parameters are used to model the behavior of aircraft and flow phenomena in wind tunnels by preserving certain similarities like Reynolds number and Mach number and geometric scaling. Engineering can be accurately simulate real world conditions in a scale down models. Wind tunnel testing Internal testing similarity parameters ensures that the aerodynamic models, aerodynamic properties, and the aerodynamic forces and the moments are accurately replicated in a scale model during internal testing and providing valuable data for aircraft design and optimization. And structural analysis. Material testing. In the mechanical engineering, similarity parameters plays a role in material testing. Engineering use them to scale specimens and loading conditions to ensure that the mechanical properties of a material can be accurately characterized in a laboratory test. And in the field of vibrations and dynamics, there are dynamic similarities. These similarity parameters are used to study and predict the dynamic behavior of structures and mechanical systems. By maintaining the dynamic similarity, engineers can perform scale model testing to understand how full-scale systems will behave under various loading conditions. And in the area of thermal analysis, the heat transfer in the aeronautical and mechanical engineering similarity parameters are crucial for modeling heat transfer in components like uh, aircraft engine and or in heat exchangers. And engineers ensure the similarities in terms of temperature gradients, thermal conductivity, and heat transfer coefficient while when conducting experiments or simulations. And in the area of aircraft design and testing, here comes Reynolds number. For aircraft, a Reynolds number is a critical parameter. It is influences the flow regime, which impacts drag, lift, and overall performance. Ensuring the similarities in a Reynolds number during testing is vital for a accurate aerodynamic analysis. Turbulence and modeling. In this turbulence and modeling, uh, the turbulence intensity and length scale in the aeronautical engineering, the similarity parameters which are related to turbulence intensity and length scale are important for simulating turbulent flow around aircraft components. And designing effective turbulence models. In the area of scale modeling, in the scale modeling, geometric scaling. Geometric scaling in both fields, geometric scaling is a crucial for creating scale models for testing and maintaining similarity in the geometry aircraft components or in mechanical systems ensures that the aerodynamic and structural thermal behavior of models accurately represents full-scale counterparts. In safety and reliability, fatigue and fracture mechanics. In the area of fatigue and fracture mechanics, the similarity parameters were used to model and predict the fatigue and fracture behavior of materials and structures, which is essential for ensuring the safety and reliability of aircraft components and mechanical systems. Whereas in the area of field structure interaction, in this aeronautical engineering, the similarities parameters are important to understand the interaction between fluid flow and structural components such as wings and fuselages. These interaction can affect the stability, control, and the aircraft engine. Uh, In the heat exchanger design, these similarity parameters will also play a major role. Like in these similarity parameters are crucial for designing efficient heat exchangers in both fields of engineers need to ensure that heat transfer characteristics of a scaled down models match those of full scale systems uh, full scale systems in both aeronautical engineering and mechanical fields, and the proper considerations and the application similarity parameters were crucial for conducting accurate experiments and simulations and tests, in which it in turn contribute to design, analysis, and safety of aircraft mechanical systems and components. Failure to account these parameters can lead to inaccurate results and potentially for unsafe design. And in enough of these, there are other there are three types of similarities in the field of aeronautical engineering. The first one is about the geometric similarity. It is a fundamental similarity. It is used to whenever we know the one of the dimension of the model and another we did not know, like we know the only length scale ratio, then we can find out the model prototype relation of the length and breadth and diameter. So R comes under the geometric sizing of a geometric similarity. It has come to this a dynamic similarity. Dynamic similarity is a similarity which is used to which is used to find out the model. If we know the one quantity of ports of a model or a prototype, then we can find out the another quantity of a model or prototype. These all about these things comes under the dynamic similarity, and whereas come to this uh, dynamic similarity and force similarity, and another one is it is the relationship between the kinematic similarity, which includes the velocity and the acceleration components. And the velocity, the velocity comes in this kinematic similarity. If we know the velocity of a prototype or a model, then we can find out the another for velocity of a prototype or model. By using Reynolds number, we can simulate both the things with the these with these. with this model and prototype parameters. Whereas come to this acceleration will also comes in the kinematic similarity by using the acceleration of a prototype or a model. We can find out the acceleration of a model or prototype. And thank you.